We're going to construct the arc of a circle that stands on a chord of length 170 millimetres in a circle of radius 100 millimetres. I'm going to be using a pen so that the writing will be clear on the video, but you should be using a pencil when you do your work. Firstly, I mark the two endpoints of the chord. Over there, I'll call that point A, and point B, and I'll start to write a bit bigger. We draw in the chord, we find the midpoint, which is going to be 85 millimetres along. Now we have to construct a right angle, a line perpendicular to the chord going through the midpoint. So I'm using my set square and I'm just drawing that up there, and I don't know how long to draw that. I have to work that out using the sagittar. And you remember we saw in the previous example, if we had a circle of radius 100 and there was a chord of length 170, so that means that the midpoint there is 85. We have a little right angle triangle happening there, and we can find out that distance, and it will be the square root of 100 squared minus 85 squared, which equals 52.7 millimetres. Then what we really want to find is that little distance up there, S, that's the sagittar. Well, just like this distance from the centre of the circle out to there is the radius of 100, the distance from there to there is also 100. So that means that our sagittar is going to be 100, which is that radius, minus this distance D that we've just calculated. And when we do that, we get 47.3. So that tells me that I now need to measure along this perpendicular a distance of 47. I'm not going to kid myself that I can measure 0.3 of a millimetre. And I mark that point there, there it is. And I call that P1, which is a point that is on the arc that I'm after. So I now know 3 points that are on that arc: A, B and P1. We draw the chord that goes from P1 to B. And we're now going to repeat the process. So that distance from P1 to B, I make that to be 96 millimetres. Half of that's 48. Mark off 48. Construct the perpendicular. Don't know how long to draw it. We're going to work it out again here in a minute. And it's going to be similar to this, only that number's not going to be 85 anymore, it's now going to be 48. And that's going to change that. To 87.7, which means that S will be 100 minus 87.7, which is 12.3. So we now have to measure, and this is millimetres, not centimetres, so we'd have to measure 12 millimetres out there, and we've found another point which I'll call P2, and we repeat the process. We go from P2 to B, draw that chord, it's 50 millimetres, halfway is 25. Construct the perpendicular. What this is, it's the perpendicular bisector of that chord. Work it out. That's now 25. So that's minus 25 squared. And when you work that through, you'll find that that distance is 3.2 millimetres. So mark off 3 millimetres, call that P3, and that's getting about the limit of where I want to go with that little arc, I think. I would now do the arc from P1 to P2. Oh, that's interesting. It's 50, the same as that guy. So this is just going to be a repeat of the previous calculations. I now know that I have to go along this little perpendicular bisector, a distance of 3, and I can call that P4. Means that these points are all out of order, but they're the order in which I calculated them. And then we would go over to the other side between A and P1 and do the same process all over again. The good thing is we've already worked out the distances, and when you've finally done enough of that, I didn't, yes I did, we can then shape through without too much trouble that arc.